Good day, everyone. I am Mr. Garth Reed, Student Ambassador in the University of Technology Jamaica and Mathematics Teacher in Training in the School of Mathematics and Statistics. Today we'll be looking at a Pure Mathematics Unit 2 question, right, on the Module 1 of the syllabus, which is Complex Numbers and Calculus 2, and the topic for today is Integration by Parts. All right. So you should remember the formula for the integration by parts. I have it here to my right, which says the integral of u dv by dx with respect to x is equal to u times v minus the integral of v du by dx with respect to x. All right. Now the question says we are to find the integral of e to the power of 3x multiplied by the sine of 2x with respect to x. All right. Now, if you look carefully, we have the integral in the form of e to the ax multiplied by the sine of bx dx. All right. Now, anytime when you have an integral in that form, or if you have an integral in the form of e to the ax cosine bx dx, you will have to do integration by parts twice. All right. We'll be required to use integration by parts twice for this question. Okay. So let us get into the question now. Now, we need to find this integral, right? And I need to choose my u term, and I also need to choose my dv by dx term, okay? So what I'm going to do is write down the general choice guide for the u term, which I will call my priority list, all right? My priority list. So the first term I will have is the ln of kx. The second term is kx to the power of n. And the third term is e to the power of kx. All right, good. Now, please note that there are no trigonometric functions in the priority list here. All right. So what this simply means is that the ln of kx, right? So the ln function has a higher priority than the exponential function and also the polynomial. All right. And the polynomial has a higher priority than the exponential. Okay. So this is my general choice for the u term. All right, my general choice guide for the u term. So what will be my u term? Here, you realize that I have e to the 3x and I have sine of 2x. Now, there are no trigonometric functions here in the priority list. So automatically, you know that u is going to be equal to the exponential term, which is e to the power of 3x. All right? And the dv by dx term is going to be equal to sine of 2x. Okay? Now, what you will be required to do here now is to differentiate the u term. All right? So we're going to say du by dx is going to be, we differentiate the power, 3x. All right? When you differentiate 3x, you get 3 and multiply it by e to the same power, 3x. Okay? And v is going to be the integral of sine 2x. Now, the integral of sine is a minus cos, all right, of the same angle. However, remember now that we also have to divide by the derivative of the angle. So when you differentiate 2x, you get 2, all right? So that is what we'll be working with. So let us now get into the question. So we want the integral, all right, we want the integral of e to the power of 3x multiplied by the sine of 2x dx, okay? And that is going to be equal to u multiplied by v. So we're going to multiply e to the 3x multiplied by the negative cosine of 2x over 2. And when I do that, I will get a negative e to the power of 3x multiplied by the cosine of 2x, all right? And I'm also going to divide that expression by 2, okay? Minus the integral of what? V du by dx, all right? So I'm going to multiply v by du. So I'm going to multiply the negative cosine 2x over 2 by the 3e to the 3x, okay? And when I do that, I will get a negative 3e to the power of 3x multiplied by the cosine of 2x. And I'm also going to divide that expression by 2, all right? Dx. Good. Now, you realize that in the integral here, I have negative 3 over 2 multiplied by e to the 3x cosine 2x. All right? Now, negative 3 over 2 is a constant. I can take out any constant outside of the integral. So that is what I'm going to do here. Okay, so let me scroll down so that we get more space. So this is now going to be equal to negative e to the 3x cosine of 2x, all right? And I'm going to divide that by 2. Now, when I take out the negative 3 over 2 outside of the integral, all right, it will turn a positive, right? Because the negative sign is also in front of the integral. So I now have a positive 3 over 2, all right, multiplied by the integral of e to the power of 3x times the cosine of 2x dx. Okay, so this is what we have. However, it is not our final answer, all right? Because now we have the integral of e to the 3x times the cosine of 2x dx. So you will be required to use integration by parts again, all right? So all of this is equal to the integral of e to the 3x times the sine of 2x dx. So now I'm going to find the integral of e to the 3x multiplied by the cosine of 2x dx, all right, in order to complete my answer. So let us do that here. So we want the integral of e to the power of 3x times the cosine of 2x dx. All right. So what is that going to be? So, okay, before I write this integral, let me just write what is v and write what is my dv by dx term. Okay, so we're going to now let u be equal to 3e to the 3x. All right, the other term is trigonometric, and we know that the trigonometric term is not in our priority list. So u is going to be equal to e to the 3x, and dv by dx is going to be the other term, which is cosine of 2x. All right, so du by dx is going to be equal to 3e to the power of 3x, and v is going to be the integral of cosine 2x. All right, now the integral of cosine is going to be a sine of the same angle, but remember now that we have to also divide it by the derivative of the angle. So when you differentiate 2x, you get 2, okay? And by the way, we don't write the plus c here. We wait until we're finished, all right? And then we write the plus c, okay? So this is not where we write the plus c, if you're wondering. Okay, so let us now calculate the integral of e to the 3x times the cosine of 3x. All right, let's do that here. So now we want the integral of e to the power of 3x times the cosine of 2x dx. Okay, so that is going to be equal to u times v. So I'm going to multiply the e to the 3x by the sine of 2x over 2. When I do that, I will get an e to the power of 3x multiplied by the sine of 2x. And I'm going to divide that expression by 2. Okay? Minus the integral of what? V du by dx. So I'm going to multiply the sine of 2x over 2 by the 3 e to the 3x. All right? So if I do that now, I will get 3 e to the power of 3x multiplied by the sine of 2x, and I'm going to divide that expression. All right, I'm dividing this expression by 2. All right, and I'm integrating with respect to x. Okay, good. Let us now scroll down so that we get more space. Okay, great. All right. So if you look inside the integral, we have 3 over 2 being multiplied by e to the 3x times the sine of 2x. Now 3 over 2 is a constant, and I can take out any constant outside of the integral. Okay? So what I have now is e to the power of 3x times the sine of 2x. All right? I'm going to divide that expression by 2. Minus what? 3 over 2 multiplied by the integral of e to the power of 3x times the sine of 2x. All right? And that is going to be the integral of e to the 3x multiplied by the cosine of 2x dx. Okay? That is my answer for that integral there. Okay, good. All right. So what I'm going to do now is just substitute the answer for that integral into here. All right. I'm going to substitute the answer for that integral right here. Okay. That is what I'm going to do. So let us do that here. So what I have now is the integral. All right. I now have the integral of e to the 3x. This is what they had originally asked us to find. All right. And we said that this is going to be the negative e to the 3x times the cosine of 2x. All right. And we are dividing that by 2. All right. Plus, we also had 3 over 2 multiplied by the integral of e to the 3x times the cosine of 2x dx. All right. Now we know this integral, which is the one above, so I'm just going to substitute that into this equation here. So what we now have is a negative e to the power of 3x times the cosine of 2x. All right. We are dividing that by 2. Plus 3 over 2 multiplied by the integral of e to the 3x times the cosine of 2x dx. We have just calculated that to be e to the power of 3x sine of 2x, all right, divided by 2, all right, dividing that by 2, minus, so let me move over so that we get more space. So minus, we're now going to have 3 over 2, all right, times the integral of e to the 3x times the sine of 2x dx. Okay, good. So that is what we have here. Now let us try and simplify this expression. So this is now going to be equal to negative e to the power of 3x times the cosine of 2x, all right, dividing this expression by 2 plus, now we have a 3 over 2 outside of the bracket, so I'm going to just distribute it inside the bracket, all right, for each term. So what we now have is a 3 e to the power of 3x times the sine of 2x, and I'm dividing also by 4. Okay, so the 2 times the 2 here will give us 4 minus distribute the 3 over 2 inside for the second term, I will get a 9, all right? I will get a 9 over 4, all right, multiplied by the integral of e to the 3x multiplied by the sine of 2x dx. Good. Now remember, on the left-hand side of the equation, we have the integral of e to the 3x multiplied by the sine of 2x dx. Okay? Now, let us do some observation. On the left-hand side, we have the integral of e to the 3x sine 2x. And on the right-hand side, we also have the integral of e to the 3x times the sine of 2x. So what I'm going to do is just bring the negative 9 over 4 times this integral to the left-hand side of the equation, all right, so that we can simplify. So what I have now is the integral, so let me write it here. We now have the integral of e to the 3x times the sine of 2x dx, all right, plus, so we carry over the negative 9 over 4 times this integral, we get a plus 9 over 4 times the integral of e to the 3x multiplied by the sine of 2x dx. And that is going to be equal to negative e to the 3x times the cosine of 2x, all right, dividing that expression by 2, all right, dividing that expression by 2, plus 3 e to the power of 3x times the sine of 2x, and I'm dividing that expression by 4. Okay, so let us now simplify the left-hand side. All right, now if you realize the integral of e to the power of 3x times the sine of 2x is a common factor, so I'm going to factor that out. Okay, so when I factor it out, I get the integral of e to the 3x multiplied by the sine of 2x dx, and I'm multiplying this integral by, so when I factor it out, when I factor out this integral in brackets, I will get 1 plus 9 over 4, okay? And that is going to be equal to, the right-hand side doesn't change, so that's negative e to the 3x times the cosine of 2x divided by 2, okay? Divided by 2 plus 3 e to the power of 3x times the sine of 2x, and I'm going to divide that by 4. Okay, good. So what can I do now? So let us now find 1 plus 9 over 4. Now 1 plus 9 over 4 is going to be 13 over 4. Okay, so I can put the 13 over 4 in front of the integral here. So what I will now have is 13 over 4 multiplied by the integral of e to the 3x, all right, e to the 3x sine of 2x dx being equal to negative e to the power of 3x cosine of 2x, all right, and we are dividing that by 2 plus 3 e to the 3x sine of 2x, and I'm going to divide that expression by 4. Okay, good. Now remember, the question asks us to find the integral of e to the 3x times the sine of 2x dx. So I will need to get rid of the 13 over 4. So what I'm going to do is divide both sides of this equation by 13 over 4. Okay? And if I do that now, I can now say, therefore, the integral of e to the power of 3x times the sine of 2x dx is equal to, when I divide the right-hand side by 13 over 4, I will get 4 over 13 multiplied by, all right, I'm going to put this second term in front since it is positive. So 3 e to the 3x sine of 2x, and I'm going to divide that expression by 4. all right? And I'm going to put the first term last. That's minus e to the power of 3x times the cosine of 2x. And I'm also dividing that by 2, okay? But remember now that you also need to add something. You need to add the arbitrary constant of integration. So plus c, okay? And that is the answer for this integral. All right, so we have successfully answered an integration by parts question in the Cape Pure Mathematics Unit 2 syllabus, all right, in Module 1. If this video was helpful for you, please ensure to like this video, subscribe to the channel, and also comment down below. All right, I am Mr. Garth Reed, student ambassador in the University of Technology Jamaica and mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.